In this video, this is your question number 2 for the EOT. So in this video, we are going to learn about electric flux. Define the electric flux. Okay, this should be the first part. How we need to define as a dot product, that is the vectors between the whom electric field and the area. Means there should be a dot product between electric field and area. Clear? Okay. At each point of the surface and express it that in an equation. Okay, this is your equation for the flux. Okay, second part. Prove that electric flux. We need to prove mathematically. Prove that electric flux passing through a closed surface. We have the two type of surface. One is the closed surface and one is the open surface. Is given by net charge, okay, Q inside. This is the keyword. This is the keyword. Because whenever we are solving any question of Gauss theorem, within the system and outside the system, both are different. Inside the surface, divide by permittivity. So what does it mean? That charge divided by permittivity, that should be equals to flux. Okay, we need to prove that. So I will prove this as a mathematical relation of the medium. Okay, we need to use as a medium also epsilon and epsilon naught. Write the Gauss law in its integral form. Integral form means closed system. Apply Gauss law to relate the net flux through the closed surface. I told you na, if we are talking about integral form, it means closed surface, and if we are talking about normal form, that is the open surface. Okay, so guys, in this part we have the two things. First thing, the electric flux. What exactly the electric flux is, what is the definition, and how can you find out the maximum and the minimum values. After that, we are going to learn the proofs, and then third part, we are going to solve the numerical. So guys, I'm not starting the numerical first. I'm going to start the basics first so that you can understand. I already write down the definition for you, and after definition, we will cover the things. So what is the definition of electric flux? So electric flux says, what is the electric flux? Electric flux says the electric field lines passing through a given area. Let's say you have any particular area, and how many line of forces are passing through it is called flux. Let's say example. Let's say this is a surface, any defined surface, and how many line of forces? These are the electrical line of forces. How many electric line of forces are passing from this area? This is called flux. So this is your electric field and this is your area A. This is your electric flux. There are two cases, case 1 and case 2. Okay, so case 1 is your open surface. Let's say this is your open surface, and we have second case for closed surface. Let's say you close something and we are talking about this area. Okay, electric field lines of forces are going out. So closed surface and open surface. So in case of open surface, we are going to directly use this equation. So where this phi is called flux, this is the symbol of electric flux. This is your electric field, E is your electric field, and A is the area, and theta is the angle between them. Okay, and second formula, that is for the closed surface. Here we are using this part. I will just I will write again for you. What is this? This is the integration first time, integration second time, and there is a circle. Circle means, this means close. This means closed. Okay. Now, what we are going to solve, the maximum and the minimum value, and we are going to learn where is the angle theta. Okay, just check. Before going to learn any part from the Gauss theorem, we need to learn about the quantities, the tensor quantity, tensor quantity. What is the meaning of tensor quantity? Tensor quantity means when a scalar, we give the direction, scalar plus given direction, given or associated direction, that is called tensor. So in this, the direction is always outward. Just remember this thing, huh? Always outward normal. I will show you how to solve this part. Let's say this is a area. Okay, this is called area. So do you know any direction for area? Generally it's a scalar quantity, yes or no? Scalar quantity. But now we are providing him this area a direction. So area with direction. And I told you outward normal. Okay. So how to show that? Let's say this is the area. So just see, let's say you can see a paper. So what should be the direction? The direction should be outward, towards yourself, and it is represented with the help of n cap. So if I write a vector, area vector, so it should be written as area multiply n cap. You remember now how to write a simple vector. Let's say vector b. How will you write it? b cap. Okay. In this, direction is along b. But here, in case of area, because it's a tensor quantity, so area I can write like a vector, which is equals to a n cap. It is given direction. Clear? This is the difference. This direction, b cap, is associated with b vector. Okay? Not given. But here in tensor, we are giving the direction, n cap, that is outward. So I will show you two cases. I will explain two cases to you so that you can understand in a better way, so that we can solve the Gauss theorem. So the first case, part 1, let's say you have this surface, okay, then outward normal is like this. Clear? Okay, case 2, if the paper is like this, you can check with your mobile, let's say, or hand. Okay, so in that case, what is the outward? This is your outward normal. Okay, so I can write a vector is equals to a, this is your magnitude, and this is your n cap. Fine? Okay. Now guys, we are going to solve two parts, maximum and the minimum. Maximum, okay, I'll make it big. Maximum and minimum flux. Okay, we know the formula. Phi is equals to EA cosine theta. Flux is equals to EA cosine of theta. First, see the diagram. Let's say we have this diagram. We have this surface, okay? Let's say this is the surface. And the case 1, you can solve easily, huh? Case 1. Because we know one thing is straight, the n cap is going outward. Let's say electric fields are going like this. Electric field is going like this. These are the electric field lines. Okay? So can I say electric field vector is equals to E multiply E cap? Fine. So can we easily find out what is the angle between them? The angle is 90 degree. How? Electric field lines, E cap is going like this, N cap is going like this. So what is the angle? 90 degree. Clear? Case 2, so that you can solve easily. Case 2. Let's say the same. I'm just going to change the shape of the surface. Let's say surface is like this. Okay. And electrical line of forces are moving like this. This is the line of forces. Electric field. So can I say E is equals to E times E cap? Fine. Okay, now tell me what is the direction of n cap. So can I say n cap is here, outward normal. So can we easily say the angle between E cap and n cap. So the theta is equals to 0 degree. Clear? So if you solve this first part now and the second part, so we know phi is equals to E vector dot A vector. Okay, now solve them properly, so that you can understand. Can I write E vector? E vector is equals to E times E cap and A vector as A times n cap. So write it. So E times E cap dot A times n cap. So take out the magnitude value. E and A both are magnitude, bracket. E cap dot n cap. So what is the angle between them? So can I say EA, angle between them is 0 degree, theta equals 0 degree. So E cap, n cap, cos of 0. No, in this case, angle is 90. First case, angle is 90. So cos of 90 degree. And cos 90 is 0. So the flux is 0. Clear, guys? Flux value is 0. Cos 90 degree is equals to 0. Fine? Okay, now case number 2. We know flux is equals to E dot A. You can just solve directly, this one. Now I'm going to use it directly from equation 1. Can I say EA bracket E cap n cap cos of 0 degree. So in that case we get the maximum value EA, and you need to remember E cap is direction. So what is the value? 1. N cap is your direction. So what is the magnitude? 1. So what we get? EA, which is your maximum value. Clear, guys? You understand the 0 value? This is your 0 value. Okay, and this is your maximum value. And so now easy to understand. Whenever your theta is 90 degree, or I'll start with 0 degree. So whenever your angle is 0 degree, flux is maximum. Okay, whenever your theta is 90 degree, flux is 0. And whenever your theta is 180 degree, flux is minimum, or you can say the negative maximum, or which is equals to minimum value. Clear, guys? Okay, now till now we have learned about the maximum minimum values and about the open values and all these things. Clear? Now what we need to understand the proof, how you can prove that Gauss theorem is equals to. Okay, now just go back to the question so that you can understand. Now just read this. What we need to prove that the electric flux, that we need to prove electric flux, which we know integration over a closed path E dot dA, we need to prove that Q divided by epsilon naught. Read the question. Prove that electric flux through a closed surface. I told you this is the equation for closed surface. Clear? Open surface is different, closed surface is different. Given by net charge. So Q net. Clear? Inside the surface. Inside means close the surface. Divide by permittivity. This is your permittivity. Clear? Of the medium. And write Gauss law in its integral form. So this is your integral, means with the help of integration. Clear? We need to prove that. Okay, now proof of Gauss theorem. Gauss theorem. So guys, what we need to prove? Flux equals integration over a closed path. This means integration or integration over a closed path E dot dA should be equals to Q net divided by epsilon naught. Clear? Okay, now it's very easy, guys. Just take any surface. Okay, consider a surface. Let's say this is a sphere. What a shape of my sphere, huh? Okay, let's say now this will be fine. Okay, let's say this is a sphere, huh? So in the sphere, solve it. So let's say this is the closed surface, and from here we are finding the value. This is your n cap, this is your e cap, and solve the value. This is your e cap. So we know LHS. So flux is equals to integration over a closed path E dot dA. Clear? Okay, now open this. Integration over a closed path E dA cos of theta. We already understand this part. Okay, and we understand both are in the same direction. E cap, n cap. So theta equals to 0 degree. So can I say when theta equals 0 degree, cos of 0 degree is equals to 1. So cos of 0 is 1. Okay, let me add a paper. Okay, now, so we have integration over a closed path E dA. So we know the value of E. What is the value of E, guys? K times, or you can say 1 over 4 pi epsilon naught, 1 over 4 pi epsilon naught Q over R square. Fine, place the value. And what is the integration of A? The flux is equals to E double integration of dA. Okay, so what is this part? Solve it. Integration of dA is the area. So we are using a sphere. So what is the area? 4 pi R square. So use the value. Flux is equals to E is 1 over 4 pi epsilon naught. 4 pi epsilon naught Q over R square. Multiply. What is the area? 4 pi R square. So cancel this. 4 pi R square. So what is left? Flux is equals to Q over epsilon naught, and which is the required proof. Clear, guys? Required proof. That we need to prove that what exactly we are proving. Flux is equals to integration over a closed path E dot dA, which should be equals to Q by epsilon naught. Fine, guys? Okay. Now we are going to solve the numerical. Numerical is just an easy part, and you can solve in an easy way. Okay? Now you will understand the numerical also. Okay, guys, just read the question, what exactly it is saying. We have a cube here. Okay? In the cube, how many faces we have? We have the 6 faces. So we need to solve the flux through all these 6 faces. Now just try to understand. Let's say I'll draw a new cube for you for the better understanding. Okay, we have this cube. Find and solve this cube. How many faces you can see? Shall I write the numbers? Okay, I will write the numbers. Let's say 1 face, 2 face, up face 3, down face 4, front face 5, 6 and 5. Okay, you can understand now all the 6 faces. Okay, now what he's exactly telling us, show that the cube has the faces of area A, all are same area. Uniform electric field means E remains same. E is perpendicular to the plane of one face of the cube. What is the net electric flux passing through the cube? Guys, what is the net flux? This is the major point. Net electric flux. How many faces? Simple question, very simple. How many faces? 6 faces. So means we need to find 6 flux. Total flux should be equals to phi phi 1 plus phi 2 plus phi 3 up to phi 6. Okay. So you need to find a phi. So what is the direction of electric field? Direction of electric field. So what is the direction? Like this. Can I say in terms of positive x-axis? Yes or no? From here you can easily understand. Let's say I'll draw the, you can see from here. This is along the positive x-axis. Okay, now just check, Okay, let's see, this is the box and you can understand from here. It is passing like this. So which area it is passing? And as per the surface, take the surfaces, Third surface, take the third surface. Where is the area? Can I say here is the area, n cap? Yes or no? Where should be the fourth? Area wise, Let's say area 1, 2, 3, 4, 5, 6. Okay, just tell me. For area 1, what is the n cap? N cap is outward. N cap is outward. Can I put here n cap? This is for area 1. And this is the electric field. Clear? So can I say theta is equals to 0 degree? Cos 0 degree is 1. So flux 1 is equals to EA cos 0, which is equals to flux is equals to EA. Clear, guys? Easy. Okay, now for second area. So where is the n cap in second area? Okay, it should be this side, n cap. So guys, n cap outward. Okay, but what is the angle? Can I say theta is equals to 180 degree? See, try to understand. It is going this side, n cap this side, electric field this side. Clear? So theta is 180 degree. So when you solve cos 180 degree, then what will you get? Flux is equals to EA cos 180. So you will get flux is equals to negative EA. Fine. Now third, 4, 5, 6. Just check the third one again. Check it properly. Where the line of forces are going? N cap this side and electric field this side. So what is the angle? See, n cap is going up, electric field is going like this. Can you see what is the angle we have? We have the angle of 90 degree. Clear? In case of 4 also, n is going down, n is going down, E is going like this. Can you see the angle 90 degree? Okay. Case 5 also, you can see front and back. So it is making an angle of N and E cap, making an angle of 90 degree. So all the 4 cases, we have flux is equals to EA cos of 90. Cos 90 degree is 0. Can I say flux is 0? Clear, guys? So we have all the 6 values: flux 1, flux 2, flux 3, flux 4, flux 5, flux 6. So just add them and finalize it. So flux is equals to flux 1 plus flux 2 up to flux 6. Put the values. What is flux 1? EA. What is flux 2? Negative of EA. Flux 3, 0. Flux 4, 0. Flux 5, 0. Flux 6, 0. So what is the net value of this 2? Plus EA and minus EA. So flux is 0. It means the line of forces. See, this is the major. Last point is the difficult most, or the most you need to focus. What is the conclusion? Conclusion is line of forces or electric field in equal electric field out. What does it mean? Let's say this is the body. Let's say 10 line of forces, 10 electric field is going inside the surface, and how many is going out? 10 electric field line of forces are going out. Means inside you have nothing. Clear? So this is the real understanding. So there is no net flux. Okay guys?